Welcome to The Explainer. Today, we're strapping in for an absolutely mind-blowing journey. I mean, literally traveling to the very edge of the universe to tackle what's arguably the hardest, most baffling problem in all of astrophysics. Picture this. You leave Earth in a spaceship, right? And you travel in a straight line forever. Will you eventually hit a giant cosmic brick wall? Will you loop all the way back around to Earth? Or are you just going to fly through a boundless, endless void for all of eternity? It's a puzzle that has completely stumped the greatest philosophers and scientists for thousands of years. But today, we're going to break it down, solve it together, and I promise you, it's going to fundamentally change how you view your place in the cosmos. Let's get into it. To kick things off and start unraveling this massive cosmic mystery, we need to answer a deceptively simple childhood question. It's kind of one of those things you might never have seriously asked yourself because, well, the answer seems painfully obvious. Why is the sky dark at night? You'd probably say, well, the sun went down and it's not lighting up my side of the Earth anymore. But think about it on a much deeper, cosmic scale for a second. Space is packed with stars, billions and billions of them. If the universe were truly infinite and eternal, meaning it's existed forever and goes on forever in literally every direction, then no matter where you look in the night sky, your line of sight should eventually hit a star or a galaxy. If that were the case, our night sky wouldn't be dark at all. No way. It would be blindingly bright, glowing as fiercely as the surface of the sun itself. But obviously, that's not what we see.
Okay, let's dive into this, because this seemingly innocent little observation actually totally breaks the idea of a simple, infinite universe. In physics, this argument is famously known as Olbers Paradox, named after the German astronomer Heinrich Wilhelm Olbers. And it is a brilliant paradox because it forces us to rethink the very limits of our reality. The sheer fact that we have a dark black sky heavily implies that the universe cannot be both infinite in size and eternal in age. Some things gotta give, right? So, what's the actual solution here? Why aren't we just completely blinded every time we look up at night?
While the answer lies in the crazy, dynamic, expanding nature of our cosmos. As the universe expands, distant galaxies are actually physically moving away from us here on Earth. And as they race away, something fascinating happens to the light they emit. The light waves literally get stretched out as they travel across this expanding space. It's like pulling on a coiled spring. The further away a galaxy is, the faster it's zooming away, and the more its light gets stretched. Eventually, this stretching shifts the light all the way toward the red end of the spectrum. For the most distant galaxies, the light stretches so much that it drops out of the visible spectrum entirely and shifts into invisible infrared. Our human eyes just simply cannot see infrared light. So believe it or not, the sky is actually filled with the light of distant stars. It's just that the sheer expansion of the universe has rendered that light entirely invisible to us.
But wait, there is another absolutely crucial piece to this puzzle. The universe is not eternal. It had a beginning. Exactly 13.8 billion years ago, the universe as you and I know it kicked off with a hot, incredibly dense Big Bang. And because the universe has a finite age, it introduces a very hard physical boundary to what we can actually observe. You see, light has a strict speed limit. So we can only see objects whose light has had exactly 13.8 billion years to travel across space to hit our telescopes. Anything beyond that distance, it's completely invisible to us, simply because its light literally hasn't had enough time to reach Earth yet. Now, what's really interesting about this is the contrast between these two mind-bending cosmic scales. Because space itself is expanding, and get this, it's expanding faster the further out you look. There's a boundary out there called the Hubble sphere. It sits about 14.4 billion light-years away. Beyond this sphere, galaxies are actually moving away from us faster than the speed of light itself. Now, you'd naturally think light emitted from beyond that boundary could never, ever reach us. But the Hubble sphere itself is actually growing. Over billions of years, it expands outward, eventually sweeping up and enveloping light that was previously losing the cosmic race. Because of this little loophole, we can actually see light from objects that are currently an astonishing 93 billion light-years across. This massive 93 billion light-year bubble is what we call the observable universe. It is the absolute true cosmic limit of our vision. No matter how advanced our telescopes or technology ever become, we will never ever see beyond this boundary.
Part 1. The shape of space.
So to figure out what lies out there beyond that 93 billion light-year boundary, we have to understand the physical geometry of space itself. Einstein's theory of general relativity basically gives us three possible options for the fabric of space-time. Einstein brilliantly showed us that space isn't just some empty void. It's a flexible, bendable fabric. And this brilliantly illustrates that at the largest cosmic scales, this fabric has to take one of three shapes. Option 1, it could have positive curvature, which would shape the universe like a giant sphere. In this kind of universe, if you drew a massive cosmic triangle, its interior angles would add up to more than 180 degrees. Option 2, it could have negative curvature, warping space into this bizarre, endless saddle shape. Here, a giant triangle's angles would actually add up to less than 180 degrees. Or option 3, space-time could be completely flat, extending out like an infinite, perfectly straight grid. In a flat universe, light travels in straight, parallel lines forever, and a giant triangle's angles add up to exactly 180 degrees, just like the standard geometry we all learned back in school.
So, out of those three, which one is it? Well, cosmologists actually went ahead and measured this. They looked at the cosmic microwave background, which is basically the faint, fading leftover radiation from the Big Bang itself. By analyzing these unbelievably tiny temperature fluctuations in this ancient light, they essentially drew those cosmic scale triangles across the entire sky. And the results? Completely astounding. The angles added up to exactly 180 degrees. This confirms that at the very largest scales, the fabric of our universe is flat. And a flat universe isn't just some quirky geometry fact. It unlocks something truly terrifying.
Part 2. Infinite space. Infinite you.
Let's move to and see how this builds, because most cosmologists agree that a flat universe doesn't have an edge. It just keeps going, forever. And if space really does go on forever, we have to confront a seriously mind-bending reality. I want you to think really closely about this logic for a second. Everything you see around you, the Earth, the device you're watching this on, your own physical body, it's all made of fundamental particles, right? But there is only a finite number of particle types in existence, and there's only a finite number of ways you can arrange them before you simply run out of unique combinations. Now, take that finite number of combinations and stretch it across a truly infinite space, filled with stars and galaxies extending forever in all directions. Statistics mathematically guarantee that those combinations must eventually repeat. That means that out there, somewhere in the infinite expanse, there is an exact copy of the Earth. And on that Earth, there is an exact copy of you, living your exact life, listening to this exact explainer right now. Crazy, right?
So the crucial point is, just how far away is this exact cosmic clone of yours? Well, using the mathematical models of an infinite universe, physicists have actually crunched the numbers and calculated the distance. Your exact copy is currently located 10 to the power of 10 to the power of 29 meters away from us right now. That is a 10 followed by 100 billion trillion zeros. Let that sink in. It is a number so staggeringly massive that our human brains literally cannot visualize it. I mean, it's enough zeros to fill billions of textbooks. It's effectively infinity. But in a truly infinite universe, it's not science fiction. It is an absolute statistical reality.
Part 3. The Fading Cosmos.
Now, as absolutely mind-blowing as it is to know that those infinite clones of you are out there, we have to face a slightly darker reality. We are never, ever going to reach them. Because space is expanding faster and faster, galaxies are constantly being pushed over that cosmic horizon we talked about earlier, that absolute boundary where space expands faster than light. Every single second that ticks by, 60,000 stars slip past this unreachable horizon. 60,000! Every second. That means just since we started this explainer a few minutes ago, tens of millions of stars have permanently left our reach. Poof, gone. Even if we built a magical spaceship traveling at exactly the speed of light, we could never catch up to them. They are locked away from us forever.
When we project this relentless expansion forward into deep, deep time, we see a grim but profoundly fascinating timeline for the future of our universe. Right now, like I said, we're losing 60,000 stars a second. Fast forward 100 billion years, and every single galaxy outside of our own local galactic neighborhood will become completely unreachable, period. Fast forward even further, to 2 trillion years from now, and those distant galaxies won't just be unreachable. Their light will be so incredibly stretched out that they will become entirely invisible. The universe as we know it today, this rich, beautiful tapestry of glowing nebulae, massive galaxy clusters, and deep space wonders, it's all going to slowly fade out of view, as if the whole thing were just slipping beyond the event horizon of a giant black hole.
Just imagine an alien civilization, or maybe even our own super distant human descendants, evolving on a planet like Earth 2 trillion years from now. When their astronomers look up through their most powerful telescopes, they're going to find nothing but silence and pitch-black darkness. They won't see a single other galaxy. To them, the entire universe will just be their one home galaxy, completely isolated in an endless void. All the evidence of the Big Bang, the cosmic microwave background, the entire history of cosmic expansion that we've mapped out, all of it will have been totally erased by the stretching of space. They'll probably just conclude that the universe is static, unchanging, and consists of absolutely nothing more than their immediate starry neighborhood. They will have no way to ever discover the dynamic, massive cosmos that you and I know exists today.
Now, I know that future sounds a little bit depressing, painting this picture of a lonely, fading cosmos. But hey, we really shouldn't feel disheartened by this. Our own Milky Way galaxy, which, by the way, will eventually merge with our neighbor, the Andromeda Galaxy, contains hundreds of billions of stars all on its own. It holds more than enough space, resources, and endless mysteries for humanity to thrive and explore for billions of years to come. I mean, we haven't even figured out how to visit the nearest star in our own cosmic backyard yet, let alone a clone 10, 100 billion trillion zeros away. So honestly, we have plenty of local exploring to do long before we ever have to worry about the rest of the universe fading away.
Which leaves us with this final, truly spectacular thought. Think about the sheer, incredible privilege of our current moment in time. Out of all the billions of years, we happen to exist right now in the exact perfect cosmic era where the universe hasn't faded to black. We live in a literal golden age of observation, where the clues to the Big Bang are actually still visible to us, where the grand, sweeping scale of the cosmos is laid out right before our eyes, allowing us to mathematically deduce that we live in a flat, infinitely expanding universe. We are literally the universe looking back at itself right when the view is at its absolute peak. So what does this all mean for you? It means keep looking up. Keep asking those massive, impossible questions, and absolutely never lose that sense of wonder.